System of linear equations. So on this first one here, it says the graph intersects exactly 1 point. So if I was to draw something somewhere's on this graph where two lines intersect, and it's not one. Give me a second and get my pen ready to go. All right. So we have two lines that intersect at 1 point. All right. So if they intersect at 1 point, we're going to have a 90-degree angle between them, and they have this 1 point in common between the two lines. Then we're going to say that this here has no solutions. Well, when I say that, or excuse me, they have one solution. My apologies, not no. They have one solution, and it's this 1 point right here. It's what they share in common between the two lines. Now, that's saying if we have parallel lines where they run beside each other, right? Their slopes are the same. That's if you draw them exactly parallel, the slopes are the same, but they share no order pair. Like this up here shared that intersection. So there's no solution. All right. Now, let's just say that you have two lines and all their order pairs are on the same line. Then we're going to call this an infinite many solutions. Okay, so that means that as long as there's arrows on it, there is infinite many solutions that those two lines share in common with each other. Okay, so now let's talk about substitution method. I'm going to put an example right here. We're going to solve substitution method. So let's use 3x plus 2y is equal to 11 and negative x plus y is equal to 3. So whenever we talk about substitution, that means we're going to solve one of these equations for x or y and then turn around and plug it into the other one. And if you notice, y here is already a positive 1. So let's just take it over here and solve for it. And when I do that, I'm going to take whatever this y is equal to here and plug it in here. And this is my substitution method. So I get 3x plus 2 times that x plus 3 equals 11. And now let's distribute. So I got 3x plus 2x plus 6 is equal to 11. And we're going to put our variable terms together. So at 3x plus 2x is 5x. Equals 11. Let's subtract 6 from both sides. And now I got 5x is equal to 6 minus 11. That gives me 5. And then we're going to divide by 5. We want a positive 1 coefficient. And so, well, I know so far my order pair is 1 for x. And now we're going to find out what y is. Well, it'd be easier if we take this one here and just plug it in right here and we'll know what y is. So we get what? 1 plus 3, which is 4. So we know the order pair for this using substitute method is 1, 4. So that tells me that these lines are perpendicular. And they share one solution. That's where they intersect at. So there's one solution. So I have an intersection here. It's not bad. So let's do one doing elimination method. So let me just, before we go any further, if you would have got 1 equals 1 and the x is not there, if you would have, for example, if it would have been 1 equals 1, then that would have been infinite many solutions. Okay. If it would have been 0 equals 1, then there would have been no solutions and they had been parallel lines. So that's just an example at looking at your answers. Now that was substitution method. I would like to do elimination method. And let me get it. I got to insert a paper. All right, let's do right here. Let's do elimination method. And I have an example I'd like to do. 3x x minus 4y is equal to 1. 2x plus 3y is equal to 12. Okay, so to do elimination, we need the x or y to cancel out. In order to do that, then I need one of them. I need to multiply each row by something to make them equal, except for opposite signs. And I already see that y has a negative and a positive. So whatever I choose to do, this would be a great option. However, I need them to be the same coefficient, just the opposite sign. So I know that 3 times 4 is 12 and 4 times 3 is 12. So I'm going to go for 12. So we're going to multiply this top row times by 3. So I got 3 times 3x is 9x. 3 times negative 4y is negative 12y. And 3 times that 1 is 3. This one here, I need 12 in that place, but I need to multiply it by 4, sometimes 4. So 4 times 2x, 8x. 4 times 3y, positive 12y. 4 times 12 is going to give me 48. And now let's add them up. Well, when I do that, what happens? The y's go away, and that's what we wanted. So now I have 9x plus 8x is 17x equals to 3 plus 48 is 51. Let's divide by 17. Because we want a coefficient of positive 1 on the x, that gives me x is equal to 3. All right, so we know we're going to have one solution because x equaled something. So what I'm going to do is, it doesn't matter which one of these original ones you plug in for x to find y. I'm going to just plug it into this bottom one. So now 2 times 3 is 6. Subtract 6 from both sides. Divide by 3, so y equals 2. So my order pair is 3, 2, and there's one solution, and it is a perpendicular lines because they do cross and intersect. I would like to do one more, just so you can see what it looks like. If they didn't, if then it's not a one solution. Okay. So let's do, and we have 3x minus 2y is equal to 4. 6x or negative 6x plus 4y is equal to 7. So what I'm going to do is use the elimination method here. And you could use substitution if you wanted, but I encourage substitution if and only if the x or y, one of them has a positive 1 or has a 1 on it, because you're going to do a lot more work. So what I noticed that my x's are negative and my y's are negative, or negative, excuse me, positive, negative, negative, positive. So it doesn't matter which one you want to pick. I'm going to go for the x because I can multiply the top by 2. So 2 times 3 is 6x. 2 times negative 2y is negative 4y. 2 times 4 is 8. And let's just bring this other one straight over. Well, what happens? Oh, this just so happens to work out that when I add and subtract, my x's go away and my y's go away, and they give me 0. They actually go to 0, right? And then 8 plus 15, or 8 plus 7 is 15. Sorry, guys. And it's not equal. So if it's not equal, these lines are parallel. And they're parallel lines. And there's no solution. So remember, if those were equal, say it was 15 equals 15, then we would have said there's infinite many solutions. And we would have said both lines were on the same line.